Hey guys, how are you doing? So this is the question from 50 challenging problems in probability. This is the question number 15 of 50 challenging problems in probability. Although it has more questions than 50, I guess. Anyways, so this is the question. It's named the theater row. First time when I was solving this type of question, I was pretty confused as to how to approach this question. So let's discuss how exactly we do these types of questions. 8 eligible bachelors and 7 beautiful models happen to randomly have purchased single seats in the same 15 seat row of a theater, right? On average, how many pairs of adjacent seats are ticketed for marriageable couples? Although in now's world, like in present world, marriageable couple is every bachelor with, like, a bachelor can also marry a bachelor. So that's not the question here. When the question was made, it asked, like, according to the solution, it asks for basically how many pairs of bachelors can sit beside beautiful models, like basically how many pairs on average will be there uh, in which bachelor and model are sitting side by side, right, among all the permutations which is possible. So when I first saw this question, I was pretty confused as to how to approach this question, right? So what I did was I thought bachelor there will be certain 8 number of bachelors and certain 8 number of models, and I thought that, like, I have to find the expected value using some I into qi, where qi is the probability that there are I bachelors are sitting, like, there are I bm pairs or mb pairs. This is what I was thinking while I was first when I was doing it, and it was immense. It is pretty much like I didn't find a solution which uses this technique till date. If you find, and if you know, please tell me how to find out this for every I. But basically it was not really under my scope, and so I thought, let's just take out the solution. I cannot know any all these all I cannot solve all the questions with my limited knowledge. So what I found out was, let's say that we select ith bachelor, okay, and this is not the solution which is shown in 50 challenging problems, but this is a very good and efficient solution, I think. Let's select the ith bachelor and jth model, okay. Let's make them set together, okay. So this guy is getting lucky and he is sitting beside a model. So there are two possibilities, bm and mb, right? So two possibilities in which they can be seated, and let's say ij are sitting, like ith bachelor I and model j are sitting together, okay. Except for them, there are how many seats left? 8 bachelors and 7, so 15 minus 2 is, like, how many seats do they have? Can you tell me how many seats do they have to sit? They can sit in this, either this dot dot dot. They have 14 seats basically. They can sit in 14 types of different seats, right? Two are the types, basically bm or mb. They can sit in 14 different seats, and except for them, there are 13 factorial people all around who can arrange themselves anywhere. We don't care. We just care about how many times these two person are sitting next to each other, right? So this is what we are trying to do right now. Okay, so I and j are sitting together in this many number of ways, okay. Can you see something that I and j number of seating arrangements, like the number of times they sit together, is totally independent of their I and j. So if we sum over all I and j, this 2 into 14 into 13 factorial, that is, we are making first bachelor sit with all the models. Then so basically it will be 7 into 8 into 7, the number of bachelors into number of models, into 2 into 14 to 13 factorial, right? So this is the total number of ways. Now we need to find the average number of, so how many total number of permutations are there of them? 15 factorial, right? So if we can see that this thing boils down to 14 factorial. So 8 into 7 into 2 into 14 factorial is already there with us, right? So so what we can do over here is what we can do over here is, this is basically the total number of ways, and this is basically the total number of arrangements of setting of I bachelors with J models, right? So it will be, so let's divide this by 15 factorial. As far as basically there are, if we divide this thing by 15 factorial, then what do we get? The average number in each permutation, because we there are total 15 factorial permutations, and we have found out the total number of times a bachelor sits beside a model, right? And 15 factorial is the total number of permutations. So dividing this by 2, so 2 into 7 into 8 by 15 will give us 2 into 7, 6, 14 into 8. I'm not liking the calculation over here, that's why I was wondering for a bit, but I'm pretty sure this is the answer. Let's generalize this for let's generalize this for more values. Like for M bachelors, let's say there are M bachelors and N models. Okay, let's generalize this. For M bachelors and N models, we can see that for ith bachelor and jth, they can set in two different ways, BM, MB, and they have 14 different types of seats to set in, and 13 factorial ways in which the others can arrange around them. That is that, and then over all the bachelors and models, we get this M and N. Oops, again I am calculating. This should be M plus N minus 1 into M plus N minus 2 is the total number of people who are not them, and then we can multiply M and N. So basically 2 into M plus N minus 1 factorial into M into N. Now we have to divide it by the total number of permutations which we can possibly have, boiling it down to 2mn by M plus N. This is the average number of bachelors and models sitting together. How many pairs of adjacent seats are ticketed for marriageable couples? Basically bachelor and models. So yeah, this is it. I hope you like the video. I hope you like the way of solving this question. I found when I first read the question, it was difficult. When I first read the solution in 50 challenging problems book, I found it a bit difficult to understand their exact solution, but I find this solution of mine pretty interesting and easy as to to understand this. So that is how I understand this, and this is how we do this question. I hope you like the video. If you like, please share it with your friends. And what if it was it was a modern day question? Let's say marriageable couple means BM, MB, MM, or BB, then any pair is marriageable, right? Any pair is marriageable. Then you can again think how exactly we will solve. So it won't be tough, and it can be also the answer can be also derived with common sense. You can think in a normal way and you can get it, because it will be same for all the permutations, right? Because anyone can marry anyone, and there will be 14 for each. So 14 into 15 factorial by 15 factorial, 14 means 7 plus 8 minus 1, because however you make them sit, there are 14 adjacent couples, right? There are 14 adjacent couples in a 15 sized row. So basically m plus n minus 1 will be the answer when anyone can marry anyone. It's the modern day marriageable couples, if we think of like that. So yeah, that's it from my side. I hope you liked the video. Let's meet in the next video. Bye bye.